Ready?
You ready?
Yes.
Oh, it's going. Okay, I'm Peter Johnson.
Robert Paul.
Savannah Martinez.
Oh. I better scoot back.
Alright. So, basically for this lab 4, we're going to be talking about aromatic, non-aromatic, and anti-aromatic. So what I'm going to go over with you right now is the requirements of aromatic, anti-aromatic, and non-aromatic. Now, for something to be aromatic, it needs to be cyclic, meaning like it's got to connect to itself, and it needs to have alternating pi electrons, and by that it means like alternating double bonds, lone pairs, a positive charge, or a radical. It also needs to be planar, which means flat. So it has to be less than 8 carbons. It also has to be a whole number when you do the 4n plus 2 formula to figure out the pi electrons. For anti-aromatic, it needs to follow the rules 1 through 3, which is cyclic, alternating pi electrons, and planar. But for it to be anti-aromatic, it needs to be at a fraction when you do the 4n plus 2 formula. Now for non-aromatic, it needs to violate one of the 3 rules. Either it can't be cyclic, it can't have alternating pi electrons, or it has to be planar. And for it to be planar, it needs to be 8 to 13 carbons long and in a straight chain. So now I'm going to hand it off to Peter, who's actually going to put some visual behind it.
Okay.
I walked away
Yes.
with the notes.
Actually, I'm just using this page. And all right, and my pencil's out of lead.
Here.
Okay. So what we're gonna do here is we got two different compounds here off of the worksheet that we're just going to talk about. And then we got this one here. This is number 12, and it's an aromatic compound. Because if you take the number of pi electrons, you have 2 pi bonds, which are counted as 2 pi electrons each. Plus, it's a negatively charged cation, so it has 2 one lone pair outside of this carbon. So all told, that means it has 6 pi electrons. So we take the formula. We have 4n plus 2 equals the number of pi, that's an upside down e, electrons. Okay, so we already figured out we have 1, 2, 3, 4, 5, 6. So this we have 6, so you've got 4n plus 2 equals 6. We have minus 2, 4n equals 4. 4 divided by 4 equals 1. So because it's a whole number, it's not a fraction, it's not a part of anything. Makes sense to here. Because at the end of the day, everything goes down, we have a 1 left over, that means that it is an aromatic compound. Because of the number using that formula. And that's the way we determine aromatic. And then we have Robert Polk who's going to talk about this other one, which is anti-aromatic.
Okay. I'm talking about anti-aromatic, and pretty much to go with the rules, you have two alternative pi bonds, okay, and that equals out to 2 on each side. So you're going to do 4n plus 2, and the number of electrons, which is 4, so that goes 4n minus 2 over 2, and then n equals 1 over 2, and that gives you an anti-aromatic. Thank you very much.